Hey guys, this video is about molecular compounds. All right, we covered ionic compounds, which was a metal plus a nonmetal. And then today we're going to look at molecular. Okay, it's different. There are no metals with moleculars. Okay, so molecular compounds have something called a covalent bond. All right, now in ionic compounds, like we talked about in the previous chapter, uh, nonmetals obtain the metal's electrons. In this case, uh, the covalent bond is a bond that's a lot weaker than the ionic bond because there's a sharing of electrons. So this is hydrogen bonded to hydrogen, and the two electrons are between the two nuclei, okay, and they're being shared between. It's a weaker bond. One hydrogen doesn't take the other ones. They're sharing it now. That's the difference between an ionic and covalent bond. So, covalent bond results from the sharing of two electrons between two atoms, essentially two nonmetals. Okay? It's a very weak bond. For example, sugar. Sugar has a tremendous amount of covalent bonds, and it melts at a very, very low temperature. Splenda melts almost in your hand if you exhale hot air on it. It's an extremely weak bond, meaning low, or 0 calories. Small amounts, very, very small amounts of heat can cause the bonds to break. Versus an ionic compound, holy heck, you have to apply a lot of heat to it to get it to break. Now, there's two types of covalent bonds. We'll talk about that later. One's called a polar, and the other is called a non-polar. When I think of a polar bond, I think of a polar bear. You have a medium-sized head and a huge torso. So one side of the molecule is larger than the other. A non-polar bond would be where both sides of the same size spheres put together. Okay, so the electronegativities are going to be very closely about the same, versus polar covalent, the electronegativities are going to be pretty far apart. Now, what is a molecule? A molecule is a neutral group of atoms joined together by covalent bonds. Okay, it may consist of two or more atoms of the same element, or two or more different atoms. This is what we consider the individual or simplest unit, and that's what a molecule is. For example, the water molecule, H2O, the hydrogen bonded to the O, bonded to the H, or the sugar molecule, sucrose. So now, there's some very important molecules that you need to be aware of. Okay, we have hydrogen, two of them put together, nitrogen, two of them put together. Notice there's subscripts of twos: oxygen, fluorine, chlorine, bromine, iodine. Now, there's a total of 7 of them. Now, look at this. It takes the shape of a 7. Okay, but this is only 6, and the 7th is over here. Just remember, the diatomic 7. These are 7 molecules that have 2 of the same atoms put together. They're very special and unique, and when we do stoichiometry or moles later on, very important when we write the equations out and you use a diatomic, you must write it as such. H2, N2, O2, F2, Cl2, Br2, I2. So essentially it's group 7A plus oxygen, nitrogen, and hydrogen. They will always form pairs. When in doubt, they were going to pair up. And there's going to be single, double, and triple bonds. Now, how this works is very simple. Hydrogen forms a single bond, nitrogen forms a triple, oxygen forms a double, and then all group 7A forms a single bond. And we're going to come back to that. But here again, single, triple, double, single. Okay? Now, what is a molecular compound? It's a compound composed of molecules. Or a group of molecules where the simplest units are molecules, essentially at least 2 different nonmetal elements. For example, a cup of water, because all the molecules in the water are the same. not just one H2O, a cup of water. All compounds are molecules, but not all molecules are compounds. That's a very important note to remember. Now, what is a molecular formula? Okay, we did this with ionic compounds. It shows the types and numbers of atoms combined in a single molecule of a molecular compound. For example, carbon dioxide is represented by CO2. Ammonia is NH3. So you have the formula. And you have the subscripts indicating the quantity of each atom present. Molecular formula is not going to be a term used for ionic compounds. And there's 5 types of molecular formulas. So let's take a look. So in your textbook, you need to know A through E. On this sheet, there's actually another one, F, we don't have to worry about. So here we have the molecular formula, structural formula, ball and stick model. This is where you have the little model kits and you put them together. Then you have perspective drawing, and then you have space filling model, which is usually done by computer software. And you're going to do that in college. If you take college chemistry or college engineering, you're going to do that. Or college level biology, you're going to learn that. But we're going to focus mostly on the structural formula in this chapter. Okay, we're going to build these structures on paper, and this is what it's going to look like, the structural formula. Okay, now let's look at some properties of molecular compounds. Like I mentioned before, they have low melting and boiling points. Okay, so some molecular compounds that are liquids must be stored in the freezer. You take them out of the freezer, they are going to evaporate very, very fast. Okay, some substances that I got to use, I had to measure them out in a freezer because if I measured them out on my lab table, it would just disappear because of the boiling points very, very low. They are gases or liquids at room temperature. Okay, most of the time they're liquids. There's very, very few solids that are molecular compounds. Very few. They do not dissolve in water or form ions. Ionic compounds, when they dissolve in water, form positive and negative ions, like you guys drew out, positive and negative ions. In this case, molecular compounds, if you take sugar, dissolve it in water, it will not conduct electricity because the sugar molecule does not break apart. It does dissolve in the water, okay? It does mix in the water, but the C, H, and O's do not come apart to form ions. It just doesn't. Okay. Lastly, molecular compounds are basically formed from 2 or more nonmetals. There will never be a metal in a molecular compound. Very, very, very rare if there is. And that's the end.